2023 was the warmest year on Earth for humanity. Our world is in trouble as the impact of climate change is increasing and creating havoc in our daily lives. The air quality is getting bad because of wildfire. Last year, summer was too hot to handle. Food prices are soaring high. And if you have experienced any of this, you are the victim of climate change. One of the main culprits for climate change is the greenhouse gas emissions from metal industry, which accounts for almost 7 to 9% of global emission. In fact, to produce 1 ton of steel, the carbon emission is equivalent to a car making a road trip from Vancouver to Nova Scotia twice. These greenhouse gases like carbon dioxide can trap Earth's heat, making it warmer, resulting into climate change. And we have been relying on these metals because of their superior properties. However, there is a way we could replace some of these materials with wood, which is sustainable, biodegradable, and has ability to sequester carbon from atmosphere while it's growing. My research involves modifying the wood to make it ultra strong to compete with steel for advanced engineering applications, from green building to even making lightweight vehicles. Wood is a porous material comprising of 3 main components. Cellulose, which is a backbone, it provides strength and has a lot of hydroxyl groups on its surface. Second is hemicellulose, which provides flexibility to the wood. And third is lignin, which is a glue component in the wood and gives stiffness to the wood. To make an ultra-strong wood, we'll start with any ordinary piece of wood. We apply chemical treatment called delignification, where we are trying to remove this lignin and hemicellulose component from the wood. The wood is pressed under hot pressure for a long time, and finally you get a densified material. By compressing, you try to align the cellulose fibers close enough that the hydroxyl groups can form a strong hydrogen bond. It has been reported that the densified material is stronger, lighter, and is comparable to metals. However, it takes 24 hours to make that one densified material, and that's where I'm trying to optimize this process so that I can make this densification time less intensive and as well as energy less intensive. I believe that by truly partnering with nature, we can revolutionize this modern material. I hope wood can one day replace steel.